so here we go with this review here. Remember, your test will be on either of these days, depending if you have 8th or 3rd or 5th period. Okay, so when you go to graph, this is an exponential function. The 1/3, that's less than 1, so that tells you that it's an exponential decay. All right, the transformations, the 4 there is going to give you a stretch. And the x minus 2 is going to move you to the right 2, and minus 5 is going to move you down 5. Okay, so remember, exponential growth or decay, like a basic decay problem looks like this, and it has an asymptote at y equals 0, right? And so what's going to move that asymptote is if your graph gets moved up or down. So since I'm moving down 5, the y equals 0 is going to change to y equals -5. We're going to use our calculator to find our x and y intercept. So let's see. 1/3 x minus 2 minus 5. All right. So we got 1/3 power x minus 2. Minus 2 minus 5. All right. All right. So when we look at the graph here, then I can go ahead and get the y-intercept, by pressing the trace, and if I type in 0, and I get 31. Okay. So there's that, and it does kind of tell me, you see this 1.79 on the screen, but I'm going to go ahead and, so when x is 0, y is 31, you can also get that from the table. You see there's 0 and 31. And so I'm going to go ahead and go back to the graph and do second calc, number 2. And I will put in, looks like it's crossing between, we'll just put from 0 to, I don't know, 5. How about? Oops. I think this thing is kind of weird. All right, so hang on a second. Let me start that again. This thing is a little bit strange. Left bound, so I'll say 0, right? Right bound, 5. All right. And so I think it's telling me 1.79. So we'll say 1.8, basically. And the other one was 31. So you know how to do that in class from your calculator. 1.8. And x-intercept is all right, so there we go. All right, so to go ahead and sketch this thing then. So 1.8 looks like about right there. 0 and 31 is obviously going to be off the screen, but I can go ahead and do my asymptote at -5. All right, and we'll go ahead and graph it here. It's going to come up and cross there. Okay, so good enough. All right, what's the domain and range? So the domain, how far left and right does this graph go? Goes forever in each direction, so -infinity to infinity. The range, on the other hand, is everything above that -5 line, so -5 to infinity. All right, I have a log function here. It's moved to the left 3 and down 1. Now, normal log function has an asymptote at x equals 0. And then the log function is, sitting over here usually. And so this is going to stay there like that, but it's moved to the left 3 and down 1. So the left 3 is going to affect, usually it has an asymptote of 0, x equals 0, so that's going to be x equals -3 now. So and this one doesn't have any stretches or shrinks, so I can pretty much track this point right here used to be 1, 0. So if I move that left 3 and down 1, it's right there. And so that's going to be kind of like the corner in a way. And then we'll just go ahead and graph it. We'll find the x-intercept and the y-intercept. So log x plus 3 minus 1. All right, so it's telling me that the x-intercept, is it telling me that thing right there? Nah. All right, so let me do the trace and 0. Actually, I'm going to look at the table. So negative 0.52. And I'll go ahead and put it on there. And then that's my y-intercept. Now my x-intercept. Let's see if I can get the calculator to do it. Let's see, number 2. So I'm going to say, how about start at 1? And I'll say let's end at maybe 8. It's somewhere in there. Oh, okay, so 7. Okay, so it's crossing at 7. And let's just check that out for a second. So my x-intercept is when the y value is 0. So I can also plug in a 0 here and have log base 10 of x plus 3 minus 1. So if I solve that, let me add 1. So I have 1 equals log base 10 of x plus 3. So look, 10 to the first has to equal x plus 3. So 10 equals x plus 3. So yeah, that's going to be 7. Okay. All right, so there's my 7. I'll go ahead and finish the graph. Okay, as x goes to negative 3, the graph goes down to negative infinity. As x goes to the right, so remember we're following the picture here. So hang on, let me get my little pointer guy here. Where is that thing? There it is. So as I go towards negative 3, the graph goes down forever. And as I go to the right, the graph goes up. All right. Sorry. Okay, so, what is the equation of the horizontal asymptote? So this is a growth problem because, you know, this E base right here, that's 2.7, about 2.7. And so this is just a growth problem. It got moved left 7 and down 14. So think of about a growth problem. It's here. Your asymptote is normally right there at y equals 0. So when you move up or down, that's what affects you. So it's this number that's affecting y equals 0. So my answer is going to be y equals negative 14. All right, here we're going to just do this on our calculator. But actually I'm going to do this by hand because you know how to do it on your calculator. So the 0, so that means the x-intercept. That means my y value is 0, right? So I got 0 equals 5 to the x minus 45. So I'm going to add 45. So 45 equals 5 to the x. So I'm going to solve this using logs. I got log base 5 of 45 equals x, right? So 5 to the x equals 45. That's what this thing is like saying here. And that's the log version of this problem here. So all I need is log base 5 of 45. So let's get out of here. I'll do my math button, find my log base. And oopsie, what happened? Oh no, guess that was an add of 45. Okay, so 2.37, let's say. And so if you did that on your calculator, that's what you should have gotten. Oops. All right, number 5, a log function. So this is ln. So remember ln is log base e, but that doesn't make a difference. A log is a log, and so normally log functions have vertical asymptotes at 0. And so in the log function sitting over here normally, and this doesn't change that, it moves left 20 and down 17. So what's affecting the asymptote is that 20. So moving yourself left 20. So there's my new asymptote. All right, for number 6, I'm going to be expanding this. And so notice here, I have one thing on top and I have one thing on bottom. So I'm going to have two logs. So I'm going to have ln of e to the third minus ln of the fourth root. So I'm going to write that as 5x minus 2 to the 1/4. All right, now this 3 can come out front. So 3 ln e minus 1/4 ln of the 5x minus 2. Now this is pretty much done, but you do have to notice that this ln of e, remember that ln is log base e. So e to the first equals e again. So this can be thought of as the number 1. This is 3 times 1. And so that's basically 3, right? So my final answer would be 3 minus 1/4 ln of 5x minus 2. All right, down here, this is going to be seen as 3 items, right? We have x plus 4 squared, we have this 5, and we have this x squared. Okay, so here we go. I have log base 5 of x plus 4 squared, so it's going to be 2 log base 5 of x plus 4, exponent to the front. Both the next things are on the bottom, so minus log base 5 of 5 and minus 2 log base 5 of x, because that square could come to the front. So the only thing I can do here is log base 5 of 5. Well, 5 to the first power is 5, so this can be thought of as the number 1. And so that's how I would simplify that. All right, on number 7, we're doing the opposite. So one thing to notice here, there's 2 ways to do it. You have 12 log base 5 of x, and you have 5 log base 5 of x. So you can subtract those right now and say that you have 7 log base 5 of x plus log base 5 of 3. So we're going to put that 7 up top, and we're going to say, hey, x to the 7th times 3. So log base 5 of 3x to the 7th, and that would be my answer. Or if you didn't notice that, then you would have put these 3 things together, and you would have said log base 5 of, you would have x to the 12th, and this one next part says minus, so you would divide that by x to the 5th, because remember these 12 and this 5 can come up here, and then plus, so times 3. Well, when you reduce this, x to the 12th over x to the 5th makes x to the 7th, so you'd get log base 5 of 3x to the 7th, and so you'd be basically in the same spot. So either way, there's your answer. And that looks a little bit strange, so let me just clean that 7 up there. All right, down here, I'm going to put that 4 up top here, put this 2 up top. All right, so I have ln of x to the 4th plus ln of 16 plus, up in the 1/3 up here, ln of 5x plus 2 to the 1/3. All right, everything's addition, so it's all multiplication. So ln of 16x to the 4th, and you could write it with parentheses, or you could put a cube root around your 5x plus 2. So either way, you would see it. Okay, for number 8, remember we're going to be trying to think of the exponent that works here. So you ask yourself, 7 to what power makes 7 again? And so 7 to the 1st. Down here, you're like, this is base 10, right? 10 to what power makes 100? And so that would be power 2. 5 to what power makes 1? 5 to the 0 makes 1. Remember, this is log base 10. 10 to what power makes negative 25? Well, nothing's going to make a negative. You can't do the log of a negative, so that is impossible. All right, remember over here, ln e. So ln is log base e. So you're thinking to yourself, e to what power makes e again? And so that would be e to the 1st. So you have ln and e, those are like they basically kind of cancel each other out and make a 1. So you can kind of use that fact here. These kind of cancel each other out, and so you're left with 3 times 7. So that's 21. All right, below that, log base 3 of 81 is 4. 3 to the 4th is 81, so 4 goes here. All right, across 25, this log base 25 of 5. So you have to think to yourself, 25 to what power makes 5? Well, I know that the square root of 25 is 5. So the square root of 25 is 5. So that's 25 to the 1/2. I would figure that out as. All right, here, this e and this ln basically knock each other out, and the 8 comes out. Right below that, ln of 0. So you're saying e to what power makes 0? and there is no such thing. You can't do the log of 0, and you cannot do the log of a negative. All right, right below that, this is 3 to the what power makes square root of 3? So that'd be 1/2, right? Because 3 to the 1/2, that's like saying square root of 3. All right, over here, 4 to what power makes 1/64? Well, I know that 4 to the 3rd is 64. And since it's creating a fraction, that's going to have to be a negative exponent. So 4 to the negative 3 equals 1/64. Okay, in the right conditions, bacteria in a petri dish grows exponentially. So there's our main thing right there. I got this data back here, and I'm going to go ahead and make an equation out of it in my calculator. And I already have it put in there. So remember to put that in your calculator. You press the stat button. You do edit. And so I already put those numbers in there. Got them all in. And then you go to, I'm going to quit out of here. I do stat, calculate. And you go down to exponential regression. There we go. And so it looks a little different on mine, but I'm going to go down to store. And I'm going to do alpha trace. And I'm going to grab y1. And then I'm going to go and calculate, right? Okay, so let's see. All right, so there's my equation. So 598.6 and 1.19 we'll say. So 598.6. All right, so there we go. There's our exponential equation. And I want a prediction for 12 days growth. So I basically want to know if the table continued, what would I expect 12 to be? So remember, the whole reason that we stored this in y1 is so that we could be here and we could do alpha trace, and we could, alpha trace, I can grab y1 and I can put in 12. All right, there we go, 4743.2. So this is bacteria, so we'll say 4743. Because it can't have part of a bacteria, right? All right, let's see. Number 10, if they exist, find the x and the y intercepts by hand. So remember that the y-intercept is very easy to find. So for the y-intercept, I'm going to be plugging in 0 for x, and that's usually very simple to do. So basically, I'm going to be having y equals 2, 0 plus 1 is 1, and then minus 5. So I get 2 minus 5, which is negative 3. And over here, if I'm doing my y-intercept, the same question. Again, very simple, just plug in 0 for x. And so I get y equals log base 4, 0 minus 2 is negative 2, and then plus 1. Well, I can't do the log of a negative, so this one does not have a y-intercept. So, and if you imagine it, you know, log function move to the right 2 and up 1, that would be like over here somewhere. So it's never going to touch the y-axis. So that should make a little bit of sense. All right, now the x-intercept is where we have some problems. Or just harder work. So the x-intercept is where you plug in 0 for y. So let's do that. So 0 equals 2 to the x plus 1 minus 5. So I have to solve this equation for x. So we're going to move the 5 over. So 5 equals 2 to the x plus 1. So I do not know a power of 2, that is 5, so I'm going to have to use a log. So I'm going to write log base 2 of 5 equals x plus 1. Because remember, I got 2 to the x plus 1 power, that's what this is saying, has to equal 5. All right, so I'm basically going to go back to my calculator and type in log base 2 of 5, and then I'm going to take away 1 from it. So that's going to be my x-intercept, because I'm going to subtract 1 to get rid of the x plus 1. So log base 2 of 5 minus 1. So log base 2 of 5. And then take away 1. So 1.32. So I would say that my x-intercept is 1.32 comma 0. All right, so here's my x-intercept and my y-intercept. All right, over here, plugging in 0 for y. So 0 equals log base 4 of x minus 2 plus 1. All right, I got to subtract the 1 so that I can put this in exponent form. So I get negative 1 equals log base 4 of x minus 2. All right, so exponent form, 4 to the negative 1 has to equal x minus 2. So you could put this in your calculator, but 4 to the negative 1 is 1/4 equals x minus 2. So you just have to add 2 to both sides. So x would be equal to 2 and 1/4. So 2 and 1/4, that's 2.25. Or you could say, 2 and 1/4, that's going to be 9/4 if you want to write it as an improper fraction. All right, so this is good enough though. So my x-intercept is 2.25, 0. Right, so x-intercept and no y-intercept. All right, just some skills you should be able to do. All right, solving equations. All right, here we go. So if possible, and remember, sometimes you can't solve an equation, like sometimes there is no solution. All right, with letter A, I'm going to be able to change the 25 and the 125 to base 5. So it's going to be 5 squared. I still have 3x plus 2 equals 5 to the 3rd, and I have 4x. So let's multiply those exponents. So I have 5 to the 6x plus 4 equals, that's going to be 5 to the 12x. So basically what we're saying here is 6x plus 4 equals 12x. All right, take away 6x, so I got 6x equals 4. So my answer is going to be 4/6, and 4/6 reduces to 2/3. All right, letter B. I have logs and I have any numbers, so I'm going to write this as an exponent eventually. So I have to take away 4 to be able to do that. So log base 8 of 2x minus 1, just cleaning this up. Take away 4, I get 2. So I'm going to write this as an exponent. So 8 squared, so that's 64, has to equal 2x minus 1. So I can just add 1 and get 65. And then my answer is 65/2. Now with logs, I need to check. If I were to put 65/2 right here, would I get 0 or a negative? And no, I would not. 65/2 plugged in right here is going to get me 2 times 65/2, which is 65. And 65 minus 1 is not 0, and it's not negative. So we're good to go. All right, this next one, I'm going to clean this up by adding 2. So I have 3 to the x plus 4 equals 12. Now I do not know a power of 3 that I can turn into 12, so I'm going to have to change this to a log. So we're going to have log with base 3 of 12 has to equal x plus 4. So just check it. 3 to the x plus 4 equals 12. So that's what this thing says. Okay. All right, so basically I'm going to go to my calculator and I'm going to type in log base 3 of 12. And then to solve for x, I'm going to be subtracting 4 from it. Okay, so you can leave your answer like this if you don't have a calculator. But if you do, log base 3 of 12 and then minus 4. So, oopsie crap. All right, what's going on here? Math up. There we go.
Calculator error makes solving math problems effortless. With photo problem solving, available on...
Sorry about that. I was trying to use this calculator so you could see it on what you're doing here, but now I've forgotten what the stupid problem was. Log base 3 of 12. All right, so we get that answer, minus 4. So negative 1.738. Okay, this was not a log problem, so we don't have to check it. All right, over here in letter D, I see all logs, and so I'm going to condense the left-hand side, and then I'm going to get rid of the log. So addition turns into multiplication. So I have ln. I'm going to be multiplying 2x by this 4 minus 16/x equals ln of 3x minus 2. All right, so basically I can drop the logs now. When I multiply 2x by this parentheses here, 2x times 4, that's 8x. And then 2x times 16/x, that's going to be 32, because the x's cancel. And then 3x minus 2. All right, so take away 3x, so that's going to be 5x equals, I'm going to add 32, so it's going to be 30. So x equals 6. And let's just check. If I put a 6 right here, that's fine. Put a 6 here. 16 over 6 is not big enough. I mean, 4 minus 16 over 6 is not going to be negative or 0. And put a 6 here. That's going to be fine. So I will accept this answer. All right, let's clean this one up. I need to get this log alone. So take away 8. I have negative 2 ln x equals negative 12. Divide by negative 2, so ln x equals 6. All right, so let's change this to an exponent. It's e, right? E to the 6th equals x. So there's my answer. And so if you wanted to go in your calculator, you could do e to the 6th. So e to the 6th, if you wanted a decimal, there it is. All right, over here, we could change this to a log, or it'd be a lot easier. 36 is just 6 squared. So then I can say negative 2k plus 5 equals 2. All right, take away 5. So negative 2k equals negative 3. So k is 3/2. All right, letter G. So in letter G, I have all logs again. So I'm going to condense this side. So that 3 is going to go up top. So I have basically log of x to the 3rd over 5 equals log of x to the 3rd plus 8. So I can drop these logs. So x to the 3rd plus 8 equals x to the 3rd over 5. So I think what I'm going to do is multiply this both sides by 5. So this would be x to the 3rd, and this would be 5x to the 3rd plus 40. All right, because remember we're distributing. All right, let's see. Take away x to the 3rd, so I have 4x to the 3rd. I'm going to move the 40 to the other side, equals negative 40. Divide by 4. X to the 3rd equals negative 10. So my answer is the cube root of negative 10. So cube roots can handle negatives, so that's fine. This is a fine answer. But when I go back and try it, if I put a negative number right here, that's not going to be good for me. So I can't do that. I do not accept this answer, so there is no solution at all. All right, in letter H, it looks like they're all logs, but I have this pesky 2 in front, so they're not all logs. So I'm going to move this log to the other side. So I got 2 equals, that negative turns positive, log base 6 of x plus log base 6 of x minus 5. So we're going to condense these. So I got a log base 6 turns into multiplication. I got x times x minus 5. I got a 2 here. All right, so time to change this to an exponent. So I get 6 squared equals x times x minus 5. So 6 squared is 36. So 36 equals x times x minus 5. So I got 36 equals x squared minus 5x. I'm going to move that 36 to the other side. Okay, so let me borrow some space here. I'm going to have to factor this. So what multiplies to 36 and makes 5 is 9 times 4, negative 9 plus 4. Okay, so my answers are 9 and negative 4. But 9 is fine here and here, but negative 4 would be a no-no in both places, actually. So I will not accept negative 4. 9 is my only answer. All right, letter I. I'm going to have to clean this up a little bit so I can turn it into a log. I'm going to take away 8. So that's going to be negative 6 times e to the 5x equals negative 18. I'm going to divide by negative 6. So e to the 5x is equal to 3. All right, so now I'm going to write it as a log. So I would write log base e. So log base e of 3 equals 5x. So basically that's ln 3 equals 5x. So x would be whatever ln 3 was divided by 5. Okay, and you can just put that in your calculator. ln 3 over 5. So ln 3 divided by 5. And there would be your decimal. Okay. All right, using my compound interest formula here. So remember, P is my principal, R is my rate, N is my number of compounds a year, and T is my time in years. So I'm going to be putting this into my calculator. I got $3,500. 1 plus R. My rate is 1.5%. So I got to change that into a decimal. So it would be 0.015. Remember, I got to move the decimal back 2 places. All right. And so, 1.5, move the decimal back 2 places. That's 0.015. over n. It says compounded monthly, so it's 12. And up top, I would put n again, so 12 times 5. That's 60 up there. All right, 3,500, 0.015, 12, 60. All right, so let's see, 3,500. 1 plus, make a little fraction here, 0.015 over 12. So this is just really a calculation that we're doing. Oopsie. All right, and I got power of 60. All right, so you'd have $3,772.42. So 3,772.42. And it's money, so obviously we're rounding to 2 decimal places. Okay, last one. So we have bacteria, half-life of 4 hours. So the bacteria continually dies off at a rate, so half the amount that was there to start with is present after 4 hours. So we have to figure out the rate. So what's happening here is that my initial amount doesn't matter, and what we're saying is that half of that is going to be left in 4 hours. So I have 1/2 of n0, so that's what I'm going to end up with when I have n0 to start, the initial amount, e to the k I don't know, but my time is 4 hours. All right, so these n0s cancel out. So I have 0.5 equals e to the 4k. So we're going to solve this by writing it as a log. So I'm going to be writing log base e of 0.5 equals 4k. And so let's check it. E to the 4k equals 0.5. That's what this says. Okay, so I need log base e of 0.5. So that's basically ln of 0.5 equals 4k. And then I'll be dividing it by 4. So ln of 0.5 divided by 4. So there's my rate, and it's negative because it's decaying, it's dying off, so that's expected. So 0.1733. Oh, 3 decimal places, so I guess we don't need that extra 3. Okay, so here's my formula. It's n equals n0 e to the negative 0.173 t. So I was just finding the rate, the k value. All right, so using my formula, let's see what happens in 15 hours if there were 3,020 bacteria to start with. So n equals 3020 e to the negative 0.173, and we got 15 up here. So this is just a calculation. 3020, let's see. Let's see, what was it? Negative 0.173. I see it up there, times 15. And 225 bacteria. So it makes sense, they were dying off, so there's less bacteria. Okay, that'll be all. I'll see you later.